Okay, so we're going to look at the distributive property or the distributive law with monomials. So by the end of this lesson, the goal is that you'll be able to actually compute some of these questions with brackets and using the operations of monomials that we had done previously. So let's just remind ourselves of some of the important things. So first of all, what did we do when we were multiplying monomials? And by a monomial, I just mean kind of like a single term or a single part where you have things connected, numbers and variables. You can see here we have one in brackets and another one in brackets. So what's going to happen when we multiply monomials? Well, what we need to do is we first of all take a look at just the coefficients, the numbers in front, multiply those two together. So you have 3 and 4. Well, 3 times 4 is just 12. So 3, 4 makes 12. Okay, next we look at the variables and match the variables. So you have an x with an x squared, and then multiply those together. And that's where we need to make use of our exponent laws. So you pretend, you don't even have to pretend, there is actually a 1 on that first one. You just don't need to write it down always. And the exponent law says when we're multiplying things with the same base, we add the exponent. So you'd have in the exponent 1 plus 2 now. So we've combined the two monomials into a single one, and we can just simplify this a little more because 1 plus 2 gives you 3. So you'd have 12x cubed. So that's a little reminder of multiplying terms like that. Okay. And let's give ourselves a little reminder of what the distributive property says. So the distributive property says that if you have a number outside of a set of brackets like we have here, instead of calculating what's inside of the brackets first and then multiplying, what we can do is we can take this number, the 2, and multiply it by each of the parts within the set of brackets. So that's why I've drawn those arrows. We're multiplying it by those parts. So let's go ahead and do that. So we'll start with 2 times, well, we have a 3x there first. So we'll write that down. 2 times 3x. And I'm just using brackets to indicate multiplication. All right. Then the distributive property says take that number 2 and also multiply it by the thing at the end there, which is a 1. 2 times 1. And what goes in between these two parts? Well, since inside of our brackets we have a minus sign, well, that's what's going to go in between them there. So you have 2 times 3x, multiplying the first two parts, subtracted by 2 times 1. And we can actually go ahead and multiply that out. So 2 times 3x, we just have to multiply the numbers out, which is 6x, minus 2 times 1, which is just going to be minus 2 now. All right. And you might be tempted to subtract 2 from 6 at this point, but this is the final answer. So I'll just say stop here. Can't combine 6x minus 2. So it's not 4x. So that is bad math if you do that. But be very careful about that. This is the final answer. The 6x minus 2. All right. So now let's get into using the distributive property when we have monomials involved in both inside and outside of the brackets. So yeah, let's take a look at the situation where you have a 2x in front instead of just a 2. Well, we're just going to treat this like we did the distributive property above. So take that 2x, and now we're going to multiply it by 3x. So that's what the distributive law says to do first. So 2x times 3x. Just going to keep things in brackets just to indicate multiplication there. And like the distributive property, take that 2x and multiply by the last part there. So 2x times 1. And again, just using brackets to indicate multiplication. But now, the only difference is we have a 2x times a 3x. So now we're going to multiply that like we did with monomials. So multiply the numbers together. So 2 and 3 becomes 6. Take a look at the variables involved. So you have an x and an x. Well, essentially you have two x's multiplied together, or an x multiplied by an x, which is the same as just x squared. And then you have a 2x at the end, since timesing by 1 just keeps it as 2x. All right, and again, stop at this point. We can't combine 6x squared and 2x since they are not like terms, so I'll just write that down as well. And that is something just to be very careful about. Not like terms. Let's continue. Okay, so now let's get into some examples. I'll go through these a little more quickly, and you can pause whenever you need to. All right, so we have x times 4 plus 5x. So again, take that number in front, the x, multiply it by the 4, and then also multiply it by the 5x. So x times 4 plus x times 5x. All right, well, x times 4, that's just the same as saying 4x. We always like to have the number out in front. That's just kind of proper form. And then in the second part, well, you have an x and an x. So the two x's together, that makes x squared. And then we just have the number, the 5. Again, we just write that in front, just proper form. Have your number in the front, then the variables afterwards. And then you can just stop at that point. You don't need to combine those two because they are not like terms. The one has an exponent 2, the other one doesn't. So you can't combine 4x and 5x squared. All right, let's take a look at 5a squared times 3a cubed minus 2. So again, when we're multiplying things in, we multiply by the entire thing that's in front of the set of brackets. So 5a squared, that entire part, is going to be multiplied by 3a cubed and the 2 there at the end. So let's go ahead and see what this looks like. So 5a squared times 3a cubed. And I'm going to include a minus sign because there's a minus sign in the brackets there. So 5a squared times, oops, almost wrote the wrong thing there, 2. All right. And again, we're using our multiplying by monomials method. So take a look at the numbers we have. 5 times 3, that's the first part we do. So 15. Then take a look at the variables that we have. So we have an a squared and an a cubed. So you're multiplying the variables together, which means you're adding the exponent. So 2 and 3 makes a to the exponent 5. All right, next we have 5a squared times 2. So you're just multiplying the 5 and the 2 together, 10, and you only have the a squared. It's not multiplying by any other variable, so you can leave it as a squared. And again, you can't combine those two terms because they are not like terms. They don't have the same exponents. All right, let's take a look at some of these examples here. So what if I had a negative number out in front? What's that going to do? So again, with the distributive property, the entire term that's in front, that's what's being multiplied into the set of brackets. And that means you include the negative sign when you're multiplying it in. So for example, for the first part, we're multiplying the negative 3 and the 5. So it's going to be negative 3x times 5x. And then for the second part, I'll include a little plus sign, then it's going to be negative 3x times 2. All right, and again, take a look at the numbers that we have. We have a 5 and a negative 3. Those two multiplied together will give you negative 15, because one's positive and one's negative. And then we have an x and an x. So those two x's, those will give you x squared. Oh, let me just write that in a regular color. All right, next we have negative 3x times 2. So negative 3 times 2, well, that will be negative 6. And you just have an x. And we aren't going to quite stop here. And the reason being is we do have a plus negative number. So whenever you see something like that where you're adding or subtracting, you have the double signs kind of happening there. Always, for simplification, turn those double signs into a single sign. So negative 15x squared. If you're adding a negative number, well, that's just the same as subtracting. So you can say subtract 6x, and we can leave it like that. All right, that's a look at that one. So let's take a look at this big one. There's multiple brackets. This will be important to go through. So when you're looking at multiple brackets, again, let's identify the thing in front of the first set of brackets, the 5x. The 5x there is only going to multiply by the parts in the first set of brackets, because in a sense it's only attached to that, and it only goes until your bracket ends. So it only goes up to that point. So we'll just start with that, multiplying the 5x by x minus 3. So the first thing is 5x times x. So again, I'm just using brackets to indicate multiplication. And then 5x times 3. And in this case, since there was the minus sign there, that's just being pulled down to be a minus sign there. All right, now let's continue. So you'll see that we're adding on this second part in a sense. So when we're adding that on, what we can do is we're just doing distributive property. So we're including everything up to the plus sign in front of the brackets. That's the part that's being multiplied into the second set of brackets. So you have the 2x times the 4x. That's going to be the first part. And then you have the 2x times the 3. And that'll be the second part. All right. And there we've applied the distributive property. So now let's go ahead and do a whole bunch of simplification. So 5x times x, well, even x and an x will become x squared. In the next part, you have 5x times 3. So the 5 and the 3 multiplied together give you 15. And there's just the x. All right. Next, we have 2x times 4x. So let's take a look at the numbers. We have 2 and 4. 2 times 4 is 8. And let's take a look at the variables, x and x. So x times x, in a sense we have 2 x's there, or x multiplied by itself, which is the same as saying x squared. And then the last part, you have 2x times 3. So the numbers together, 2 times 3 gives you 6, and there's just an x left over there. All right. So in this one, we aren't actually done yet, because this is a case where we can collect like terms. The reason being is there are things that look exactly identical in terms of the variables involved. So for example, the first term has the variable x with an exponent 2. So if we want to find another like term, we need to look for something else with an x and an exponent 2. And we do have that with the 8x squared. So when we're combining like terms, we just need to remember we're just combining the coefficients. So since it's 5x squared at the front and plus 8x squared, so don't forget about the sign in front of that number, that's going to be 5 plus 8, which is 13x squared. I'll just draw arrows to indicate where that's kind of coming from. So those two together. All right, and then similarly, we can take a look at the other terms. So we have this term with just the variable x. So let's look for anything else with just the variable x and no exponent. And we have this at the end. All right, and when we combine them, don't forget about the sign in front. So you have a minus sign in front of the 15. So it would be minus 15 plus 6. Minus 15 plus 6 is the same as minus 9. So you'd get minus 9x. And again, I'll just draw some arrows just to indicate where those are being combined. So those two together make minus 9x. Then we stop there because the x squared and the x, different exponents. The one has a 2, the one doesn't have the exponent written. So they can't be combined. All right. And that's everything for this lesson.